Right, number 269, and straight away, not going to bother with the sketch. That's a bit lazy. Right, so we are going to do the x-intercepts, the derivative function, and so forth. But the key thing here is we should be able to get a feel for what we're looking for by graphing it. Now, obviously, uh, I have set up here already that's what the graph looks like, but that you're not allowed to use Desmos, am I aware of, in the assessment. So um, there is what's just happened here. We've gone on to graph, pushed enter. There's the function. Now draw it. Now it depends on what your setup is. Okay, just shift the window. Standard is a -10 by positive 10 x-axis, negative y by 10y. Let's see what that looks like. Even worse. So what we need to do is zoom in. And obviously that's -10 there, that is 10. So what we could do is, let's say negative, I don't know, 3, 3 scale. Each notch is worth 1. Not quite sure what dots are. Oops, that's clever. I only just adjusted one thing. Let's just do that. Go down again. -3, 3, and okay, we still need to, yeah, so obviously we're saying -1 and 2, and let's, yeah, so what I'm doing here, you're just getting the confidence with what you're trying to do here, and enter, so 2, let's go -2 and 1. Okay, and also gsolve tells you maximum is going to be there, 0, 0, and push the bar. Nope. Shift gsol minima. Okay, now that point there is going to be the interesting one to work out algebraically. And shift gsol for intercepts. In other words, they use the word here root, and it's going to be 0 and 1, I believe. So that's that first one. Now push cursor. It'll take you, it's thinking that when that black dot's there, and there's the second one. At x equals 1 is 0. So there you go. Just proved that you've just got the answers to most of this here already. So, but the key skill set, folks, sadly, is not to be able to use this technology, but can we algebraically get those answers? That's our challenge. So the intercept is when the curve, basically, the intercept is when you've put f of x equal to 0. Okay, so let's just do that now. Let's bring this down here. 3 bracket x 5 third minus x 4 thirds equal to 0. The first thing that's going to go is the 3. Now, basically, look for the, if we looked at x 5 over 3, I hope you can agree with me here. I could rewrite that as x, how do I say this? 4 over 3 times x 1/3. Okay, so is that the same thing? If I said x to the power of 6, that's like saying x 4 times x2. 4 plus 2 is 6. So here is 4/3 plus 1/3. Is that 5/3? Yes, it is. Now, why have I done that? First of all, let's get rid of that 3. If I were to rewrite this like this, what do you notice we can do? We can take a common factor of x 4/3 out. So x 4/3, x 1/3 minus 1 equal to 0. Now, okay, just keep it simple. If I said something like this, if I said x 3x minus 2 equal to 0, you could solve. One solution x equals 0, and the other one would be what? positive 2/3. Same thing's happening here. So one solution is we're saying x 4/3 is equal to 0. Now, how do we solve this? That's to the power of 4/3. If we said to the power of 3/4 on both sides, that cancels out x equals 1, and 0 to the power of anything is going to be 0. So that's one solution there, x equals 0. And obviously that's the intercept of that one there. And now if we take this expression here, x 1/3 equals 1. Take the cubed of both sides, that cancels. What's 1 cubed? It's 1. So there are two intercepts when x equals 0 and when x equals 1. The derivative function. Okay, the good news is this is not so scary. F dashed of x. Okay, so this, the 5/3 comes down. What's 3 times 5 over 3? It's 5. And subtract off, subtract 1 off that. So 5/3 minus 1 is going to be 2/3. So it's going to be x 2/3. And this one here, that's going to be 3 times 4/3 is going to be 4, and subtract off 1 there is going to be x 1/3. Okay, and find the maximum minimum values. Obviously, we can straight away see what they are from the graph work. The minimum's down here. And don't forget, we could have, we can find that minimum using this thing. But algebraically, let's just, so put this equal to 0. So same process, 5x minus 4x 1/3 equal to 0. Can you see that 2/3? What's 2/3? X 2/3 is like saying x 1/3, x 1/3. Okay, so we can take a common factor of 1/3 out. What's left? 5x 1/3 minus 4. Okay, let's just check. X to the power of 1/3 times that would give you that. Yes, x 1/3 times that would give you that. Okay, one solution. X to the power of a third equals 0. So that means one solution, x equals 0. And this one here is the interesting one. So let's look at this one here. 5x 1/3 equals 4. X 1/3 equals 4/5. Okay, let's take the cubed root of both sides. That gives you x. 4 cubed is 64. 5 cubed is 125. And if you go on your calculator, 64, oh, there it is, 0.512. So we've just established that the two turning points occur at x equals 0 and x equals 0.5. But the question does ask for the maximum and minimum points. So I guess the quickest way is graphically to prove, okay, that's, how do we know that coordinate point is 0? So you could go back to here and put 0, put 0 in the original function. What happens? 0 to that, 0, so 3 times that's going to be 0. So one coordinate point, and that there is the maxima by visual. Sorry, there it is. And the other one is if we put this f 0.512 into this horrific thing here, trust me, out's going to pop negative 0.245 something or other. Okay, that's what's going to pop out. And I guess that's just me cheating. Negative 0.2458, around that 40p's. So the coordinate point there was 0.512 neg 0.2458, and that is a minima. And state the functions, the values of the function of x is increasing. So what's increasing mean? Increasing means the derivative function is greater than 0. So our derivative function was this one here. And basically we're to say that's greater than 0. And we can just sort of cheat here. Where is the grade? Yeah, so anything less than 0, you got a positive gradient. Not between 0 and 1, not between 0 and 0.512. So that zone in there would be decreasing. That's increasing gradient, and from this point here onwards, let's just put those as x equals 0.512. So anything above that, you've got increasing function. Anything below this one here, okay, this side here, increasing function. In between 0 and 0.512, you've got a decreasing function. So we've just answered a reasonably intense. What was really fiddly about this was just your ability to not get phased by these horrible indices or exponents there, and just sticking to the game plan, doing some good factorizing, and getting the end result in the end. But the key thing is using what? Using technology, might as well. And obviously I was cheating by using the awesome Desmos, might as well.